Hey everyone, can you hear me? I think I can hear me. Good afternoon, and I don't see coffee on anyone's hands. So I'm assuming everybody's awake, all pumped up and ready for the party in the evening? Okay, so we are going to talk about best practices of leveraging Amazon Analytics services with DBT. I'm myself Neela Kulkarni. I'm a solution architect with AWS. Been with AWS 3 years now. I'm based out of New York. And this is the second year I'm here at Coalesce, and this has been my favorite conference to go to. In audience, we do have some of our specialist teams and product teams. So in case you have questions after the session, please do stop by. We will try and address them after the session. With that, I will hand it over to Venki.
No, you want to introduce yourself, maybe? Me? Yeah. And then I can take over. Yeah.
I'm Nori, the principal big data architect aligned with AWS Analytics services such as AWS Glue and Amazon SageMaker. Nice meeting you.
Yeah. And hey, everyone. I'm Venkatesh, a partner solutions architect at AWS, supporting DBT. So my role as a PSA is to join forces with partners such as DBT and co-build, co-market, co-sell, ultimately help our joint customers. So in today's agenda, we're just going to go over some DBT use cases that's being used with AWS Analytics services, and some customer success stories that we have seen, and what are some of the common trends and common patterns that we have seen among the customers using DBT along with the AWS Analytics services, and a quick demo that Nori is going to show us, and go over some best practices that we could follow, or recommended best practices in performance optimization, focused on Redshift primarily, and few other services, all the services. Okay. Cool. Just by the show of hands, how many of you are already using AWS Analytics services in some capacity? Oh, almost like 50%. Good. I could probably skip some of the slides. So, I just want to start with, we have been talking about AI all over. So here in the slides, I want to start talking with how a data foundation is strongly required for your AI apps and your agentic apps to work and deliver what you need it to deliver. In the past 18 months or so, we have seen AI grow so fast. We all have evidenced it. If you have come to our other presentation that we had a couple of hours back, we spoke about 2023 being the year of POC, 2024 being the year of production, and 2025 being the year of business value, where everyone is now being, okay, I have invested so much money, where is the return, right? So ultimately, your Gen AI apps or agentic AI apps are going to be only so good as your data. How much access do you give your apps to your data, and then how much are they able to leverage the information from it and then be able to provide you with relevant responses. And this data foundation rests on 3 primary pillars here that you see on the screen: data storage and management, data processing, transformation, and governance and catalog. So if you think of all enterprises who already have their data lakes or warehouses or lake houses all built in, it may make sense to extend that architecture that they already have to cater to their AI application needs. Basically, have their AI apps leverage their enterprise data architecture to get them what they want out of that, right? Rather than having silos sit somewhere and then how the apps accessing the silos. There's so many animations here, so I had to click so many times to get the slide in full. So if we take a look at how AWS is helping this scenario, AWS has comprehensive data services for the various different categories that you see on the screen here. First, S3 being our powerhouse storage. And now with S3 Vector in preview, that becomes the first cloud object storage to get the GenAI apps or agentic AI apps to access these vector stores in a massive scale, right? And our database services, which already have fast creation, scale to zero pricing, and instant scalability to hundreds of millions of operations per second and millisecond latency. Several of them are now extended with AI services or capabilities that you can use in your generative AI or agentic AI application development readily. And streaming, so your Gen AI apps, they need live data many times, be it from IoT sensors, be it from market data, be it from any kind of such. And our streaming services such as MSK, Kinesis, they can handle massive volumes of data in real time. And we have processing analytic services, EMR for big data workloads, Glue for ETL, and Redshift for data warehouse. So all of these, or many of these services are having extended capabilities now that you can utilize in your agentic AI application development. So now, talking about how AWS and dbt work together. AWS and DB are strategic partners. We have several integrations, like dbt is integrated with several of AWS services, EMR, Athena, Glue, and Redshift you see here with those. Most of them are supported both on dbt Cloud Platform as well as dbt Core. Glue is, as of now, just on Core. And in addition to these integrations, dbt is also Redshift service-ready and private link service-ready partner. For people who may not be very familiar with what service-ready means, service-ready is a program we have in AWS that validates how the ISV partner solution has followed the best practices in integrating with some of the AWS services. It varies from service to service, but these are the service-ready designations that dbt has. And going to the next slide. Based on what you have seen as common pattern from customers' usage about how customers are using dbt and AWS services together, data comes from a variety of sources, file databases, streaming data. They typically use, we have seen customers use either Redshift warehouse or S3 data lake. And we have seen both, a good amount of both the combinations together. And house the data in a raw table and then use dbt to transform them over to intermediate or staging area, and then create views or material views out of it, and then visualize them and use them for any downstream apps that they need. And we have seen all these adapters that we saw in the previous slide work very well with many of the customer scenarios that we have, and have got good feedback on. And now I'll invite Nori over to take us through why customers are using, AWS customers are using dbt, and also to go over some very specific customer use cases and stories.
Thank you, Benki.
Sure.
Can you hear me? Yeah, okay, nice. So let me cover the typical reason why AWS customers are using dbt with AWS Analytics offering. We helped a lot of customers using dbt with AWS, and we noticed that customers are deploying the analytics code very quickly and collaboratively with following the software engineering best practices into data space. It includes these populars like modularity, portability, CI/CD, and documentation. They really want to enable anyone on the team to safely contribute to the production-grade data pipeline with dbt. These customers tell us the interesting story that they want to scale their data platform by making more teams responsible for their own data. With central teams only manage the tooling, not the entire data pipeline. They also require easy-to-use tools to go from the data exploration to the data pipeline. And there is a very good fit with between dbt and the AWS Analytics offering. There is a very interesting customer story from the BMW Group. BMW is one of our largest customers who are using dbt along with AWS Analytics services. They needed to process the terabytes of data coming from the multiple data stores day by day. And originally, they were using Terraform to create a table definition, manage the table update, and so on. Their traditional ETL process were becoming too complex and too expensive to maintain for a long time. And previously, they needed to scan the large amount of raw data day to day, and it caused increased costs in their analytics engine. To address those challenges, they introduced dbt with AWS Athena, which is our AWS ad hoc query engine. With this architecture. With this architecture, they were able to take advantage of Athena's scalable query engine, along with dbt's powerful incremental model processing. And with this architecture, they materialized the complex ETL queries and then made the dashboard query further efficient. Here's the outcome. So after introducing dbt with AWS Analytics, they were able to successfully process the terabytes of data per day with dbt. And they were also able to reduce the transformation transformation time from hours to minutes, which is a significant outcome for them. And this slide shows the chart of the cost over time. At the end of 2023, they introduced a new architecture using dbt with AWS Athena. Yeah, and the dark blue shows the cost with dbt, and light green shows the cost with QuickSight. You will notice that the dark blue, like dbt-based cost went up, and QuickSight-related cost went down, and overall cost went down significantly. This means that you passed the pre-processing to dbt. Now, before that, they needed to process the very complex views from the QuickSight dashboard, and it is causing too much computation. But with dbt, after they introduced, then they were able to materialize all these very complex query processing to dbt model. Then they had the tables, which is already pre-processed, and they were able to achieve this significant outcome. We helped many customers with dbt with AWS Analytics, and we observed two interesting trends in the customer use cases. The one is the data transformation at scale. The many organizations are standardizing on the modern data transformation frameworks using dbt across their different analytics environments. And even if they switch the data store from one to another, they tend to continue using the dbt-based unified framework because they really like it. The second thing is that some of our customers, the data teams, are processing hundreds of terabytes of data per day using AWS Analytics services with dbt. So they are using Athena, they are using Glue with dbt to process this kind of the huge amount of data by the unified dbt framework. Another interesting trend is, Apache Iceberg. As you see in the keynote, the Iceberg is becoming more popular than before. Iceberg is an open table format which allows you to achieve AC transactions on S3 or other cloud vendor storage, data lakes. With Iceberg, you can achieve the similar capability to the data warehouses, and you can achieve upsert, you can achieve the data time travel queries, and so on. So many customers recently choose Iceberg for their primary data store and make it very broadly common in their data platform. Here's a very common pattern we observe with Apache Iceberg. The customers are bringing data from sources, then place it in the general purpose bucket in the raw table format such as Parquet or CSV or JSON and so on. Then they use dbt transformation to convert the raw data to the Iceberg data, which is intermediate table. Then after that, they use dbt transforms again to convert from intermediate state to the golden table, which is consumed by different consumption layers such as BI, AI, ML, and dashboard. Let me pause a little bit here to introduce our new offering about Amazon S3 tables. Amazon S3 tables is something we released at re:Invent last year. And S3 tables is unlike S3 general purpose bucket, which is the managed Iceberg table, purely managed by AWS. With S3 tables, you can achieve the Iceberg API or the Iceberg API, but you don't need to take care of the data layout because the compaction, snapshot exploration, orphan validation, those kind of complex data management and maintenance is completely done by AWS. This is something we designed to enable a lot of customers who want to use Iceberg, but who don't want to think about the complexity of Iceberg. And today's session, I am going to showcase the demo with Amazon S3 tables with dbt. But before that, if you don't mind, can you come close? Because the demo has a little bit small font. So if you want to see the demo, then it will be better to come here. Then it will be easier for you to watch the demo. Thank you. Thank you for your cooperation. Thank you. This morning, I released the new version of dbt adapter, and it better supports S3 tables. So you can use that from today with Amazon S3 tables. In this demo, I am going to transform the two CSV tables, which is stored in my S3 bucket. Then I will use dbt core to transform data from the raw CSV table to Amazon S3 table. Then I will also apply the same another dbt model to convert the intermediate table to the golden table. Then I will use Amazon Athena to show how the table looks like. This is the Amazon Athena console. And I am going to show the original S3 CSV tables. If you open this and you choose the new databases, you will notice that there are 4 tables. There is a customer tables. It has the customer name, email, something like that. And I have also the orders table, which has the fictional order history. It's a kind of factor table. Now I am going back to the S3 console. Then this is the Amazon S3 tables console, which is really different from the standard S3 bucket. Now you don't see any S3 tables yet. So there is no tables shown up. We are going to create 4 different tables here. So let me start, keep going. And in this console, I am going to showcase one of my sample projects. Let me show the project YAML file and I will pause it here. So this is my simple project YAML definition. And as you notice that there is a file format definition in the middle, and it says S3 tables, which is the new primitive for this adapter. They usually use Parquet or Iceberg or Delta or something like that. But in this demo, we are using S3 tables for file format. Let me resume the demo. And also, I am showing some of the model files I created. Right here, in staging directory, I have 2 model files. In mart directory, I have also 2 different model files. I am showing one of the model files here, and let me pause here. In this model file, you see the select query, but in the beginning of the query, you see the configuration, which is coming from the Ginger template, which is coming from DBT. And I am using incremental model materialization, which is supported by DBT. And I am using file format equal S3 tables. Okay? So it means we are going to select the source tables, then create new S3 tables based on this query. Now I'm going to run the dbt run command using this model file and using this profile. Under the hood, we are spinning up the AWS Guru interactive session, which is an ephemeral Apache Spark cluster, and running the same query to generate the two S3 tables for intermediate state, and then two more S3 tables for the data mart. You are seeing some of the debug messages, but in the actual version, you won't see this kind of debug message. Now the dbt run finished. It means the transformation already finished. If you refresh the table, then you will see the 4 new tables in the Amazon S3 tables console. Then if you go to Athena, then of course it is accessible from Athena. So you need to choose the S3 table catalog. Then you see 4 different tables. If you preview the tables, then you can see those tables. So these are accessible from any Iceberg-supported query engine or different tools. This is the demo I prepared for this session. I hope you enjoyed it. And next, from this, we are going to showcase some of the best practices we have. Over to Nira.
Thank you. Thanks, Nori. I think now I have seen that a lot of customers are really asking for S3 table and DBT integration. And now since we have this DBT glue adapter ready, you can start using it from today itself, right, Nori? Yeah, okay. So let's talk about some of the best practices. And I know I still have some time. So DBT Fusion Engine. Yesterday's keynote was about DBT Fusion Engine. And Elias yesterday mentioned that how DBT Fusion Engine is really able to do the cost optimization. If you are using, one of the things is DBT Fusion Engine as of now is available only with Redshift. So if you're using Redshift and you want to reduce the compute cost, you can start using DBT Fusion Engine. And a couple of things that you have is a state-aware orchestration in that, where basically it will understand if it's a new model that you're creating, it will run those models. If it's an incremental run, then it will only run those incrementals around it. In Redshift, we have something called workload management. So you should start using workload management because let's say if you have to do a query optimization or query performance optimization, and you have a DBT transformation project or model that's going to be very resource intensive. And at the same time, you also have other resources who are using some of the, performing their, let's say, reporting application. When you want to make sure that you create a separate queue queries for them, so that when DBT transformations are getting executed, it's not impacting your other applications to that. We also have something called auto workload management. So if you are automatic workload management, so you should enable automatic workload management, where you don't really have to take care of anything. Redshift as a managed service will take care of how the queries are prioritized, how the resources will be allocated. QMAR is a query monitoring rule. Basically, in case your transformations are running for longer duration, you want to make sure that you set up these QMAR rules and you won't have any runaway queries. With Athena, right now there is a limitation where you can have 100 partitions when you are either inserting or creating partitions. So make sure when your DBT model is getting created, you're not exceeding those number of partitions. The DML query timeout. The timeout for Athena right now is 30 minutes. And if you have longer running queries or models, we would encourage you to change that timeout value to 240. And for that, you have to go to our service quota request on AWS console and request for it. Pricing options. So as you all know, AWS has different pricing options. One is pay as you go. So in this case, pay per query and pay for compute, so which is provision throughput. In this case, so let's assume that there are certain queries. The pay per query cost is basically based on how much data is getting scanned per query. So that is how it will get charged. So in case you have some of the DBT models that is going to have the larger scans, we should suggest that you go for pay for compute, just because there's larger data set getting scanned, number of queries are getting executed are large, your cost may go up. So in that case, using the provision capacity or provision compute might be helpful. But the drawback that comes with provision capacity is if you don't have the jobs that are not running at certain duration, you might still get charged. So you want to make sure when you are looking at your workload, you understand what are the patterns. Compute optimization. So we just looked at the glue adapter, and with the latest glue adapter 3.0, we have enabled auto scaling. By default, it is fixed scale. When you enable the auto scaling based on your workload, you will get cost optimized performance. Also, it is important for you to understand how is your workload, right? So if it is a compute intense, is it a memory intense, is it a streaming workload? So based on that, you need to choose the right worker types. Anybody using glue adapter with DBT today? Yeah. So have you seen that if you're running the glue adapter and you run DBT run commands, glue adapt this every time it creates a new session. So let's assume that you want to have the historical data passed into the next session. How would you do it? That is where the glue session reuse come into picture, where your cold start latency gets reduced. So if you want to share the data between the sessions, set that value. If you're using the file formats like Parquet or OCR, then that file format will get processed faster. That will optimize your processing. And it also depends on the compression that you're going to use. So if you add compression, obviously there will be some compute associated with it, because you have to compress it, decompress it. So make sure that you're using right compressions. How many of you are using S3? Everybody. Do you know how many storage classes S3 offers? S3 offers close to 8 storage classes. And that is what we want to see. That. And every class has its purpose, I wanted to say. Every class has a purpose. So in case your data access patterns, based on your data access patterns, you need to make sure what storage class you're using. If you don't want to make that decision, turn on the intelligent tiering. Intelligent tiering automatically moves the data based on your access pattern into right bucket. And lifecycle policies. So if you don't want data, if your data is not being accessed, move it into the different storage class, which will be cheaper. And if it's not going to be used at all, expire it. Don't keep it there, so don't get charged. Iceberg tables. Nori was explaining more about iceberg table, right? Iceberg tables, when you are creating the records or inserting the records into iceberg table, small data files get created. Those get stored in S3 bucket. At the same time, there will be snapshots getting created. So those snapshots, so you want to make sure that you are compacting those S3 files so that you won't get cost. There won't be a cost associated with the storage. You have snapshot, so that snapshot get expired or deleted. So you will be able to optimize the performance there. And S3 table, Nori mentioned that S3 table is automatically coming with this feature. Just to conclude, we have seen dbt and AWS Analytics services. They are delivering powerful and scalable solutions. We have a future-ready architecture now with dbt, Apache Iceberg, and S3 tables. So that is going to be that's going to be a foundation for our open lakehouse architectures. And there are some of the optimization strategies that we just discussed, and there are more that we can discuss after these sessions, or you can connect us on LinkedIn, and we can discuss more on that. With that, I think I'm almost at the time. Thank you, everyone.